Good morning, grade 8. How are you today? Our lesson is about scientific notation. We will recognize and use scientific notation. Now, and at the end of this lesson, you will be able to express numbers that are so small or so big in scientific and decimal notation. But let's first, if you actually been asked to find out or to research or make a research about the wide of the universe, now you will find or you will discover that it's a so big number that has 22 zeros in it. Okay, so it's difficult for you to write it. Why, miss? Because to write these numbers in your research, in your let's say in articles about the wide or articles about the universe, writing all of these zeros will confuse the readers and will sometimes maybe you will lose or forget to write some zeros. So it's difficult to deal with numbers that they are so big or even numbers that they are so small, like for example finding out the distances inside cells in human bodies. Okay, now this is why we use the scientific notation. This is why we write these numbers like this, so big like these numbers or so small. Yes, it's easier for us to write them in scientific notation. Now, a number is expressed in scientific notation when it's in the form of a times 10 to the power n. And every, let's say every variable in it, you will find out that it has condition to be written. For example, a, it must be between 1 and 10. So you should write it in ones or in decimals. Okay, but the largest number in a, okay, the largest, let's say, digits, it should be in ones only. Okay, and n is an integer. An integer, it means it could be positive, it could be negative. Okay, and notice that the base of this exponent is 10. It cannot be 100, it cannot be 1/10, it must be 10. Okay, so a, it's a number between 1 and 10, it's less than 10. Okay, so it should be in ones or sometimes in decimals that have the ones as the maximum place value digit. Now n is an integer, so it could be positive, it could be negative. Okay, as we have said before, positive it means it's a very big number, and negative it means it's so small number because actually it's so small fraction. When using scientific notation, there are two kinds of exponent, as we said, positive and negative. Now, positive exponent like 2.35, or 2 and 35 hundredths times 10 to the power 8. Now, a negative exponent like, for example, this example, 3.97 times 10 to the power negative 7. Now, when changing scientific notation to standard form, standard form, it's a number without writing, the exponent, okay, and without writing the powers and exponent. It's only the numbers we usually see, okay? The exponent tells you if you should move the decimal. Now, look, miss, with a positive exponent, move the decimal to the right. This means if I want to change my number from the scientific notation form into number in standard form, and my exponent was in positive, I will move the decimal point to the right. Why, miss? Because I want big number, okay? So, for example, if you want to write 4.8 times 10 to the power 3, I want you to write it in standard form, as a number without exponents. You will just move the decimal point 3 digits to the right, 3 digits to the right. So it will be 4080, okay? Now, if, as they say, if there are no digits, you have to put zeros, okay? with when the place value has no digit in it. Now, or the place of the number has no digit in it. When changing scientific notation to standard notation, the exponent tells you if you should move the decimal. It means that with, as we have said before about positive, now about negative, with a negative exponent, move the decimal point to the left. So why to the left? Because I'm talking about very small number. So the negative sign, it tells you that your number actually it's in decimals. Okay. Now again, you have to move it, as we have said, how many digits? Okay, you have to move it 3 digits. Okay. So as you can see here, this is 1, and you have to fill the places that have no or the no digits. You have to fill them with 0. And as you can see, we move the decimal points 3 digits till here. Okay. An easy way to remember this is if an exponent is positive, the number gets larger. So move the decimal point to the right, as I said before. Now, when your exponent is negative, so the number gets smaller. So you should know that you will have a very small number. Okay, so your decimal point should be moved to the left, so that you will tell others that this number is small. Now, the exponent also tells you how many spaces to move the decimal. How is that? Now, when you notice that you have, look, 3 exponents, the n is power 3, okay? So you have to move the decimal point to the right 3 digits, okay? Now, you move it the first 2 digits, okay? As you can see, 3 spaces, as you can see here, and the last space, the third space, has no digit in it, so you should add 0. Okay, while when you move it to the right, okay, again it's 3 spaces or 3 digits to the right. You have only the decimal points have only to the left. In exponents, when they are negative, to the left. Now you find out that when you move the decimal point to the left 1 place or 1 space of you have, then you have no digits and no spaces to the left of number 4. You should fill it with 0. You should add zeros. In this problem, the exponent is -3, so the decimal moves 3 spaces to the right. Now, let's work on these, numbers from scientific notation. If I ask you please to change them, okay, to write them in the standard form, it means I want you to write them without exponents, without, the form of times 10 to the power 4. I don't want you to write them in this form. I want you to write them in what's this? In a number, okay? Even if it was decimal or it was so big number. Now here you see that you have to move it to the right, because actually the exponent it's in positive, so you have to move the decimal point to the right. How many digits? 4 digits. You have a 3, so you have to add 0. Okay. Here you have to move it to the left 3 digits. You have only 1 digit to the left of the decimal point, so you have to add 2 zeros before you put the decimal point. Notice here that the decimal point is gone, but here we still have it in so small numbers, and it's when your exponent is negative, it's so obvious that you will still have the decimal point, because you are talking about so small numbers. Now, for example, here you will move it to the right 7 digits. So 1, 2, 3, 4, 5, 6, 7. Look, you can see here, even here you still have the decimal point. Okay? Now, so sometimes you may have the decimal point inside the positive when you have positive exponents, but it's clear that when you have negative exponents, usually you will have it. Okay, look here, I will move it to the left 5 digits. One of them will be to the left to 4, so I still have 4 zeros to be added. 1, 2, 3, 4 zeros. Okay, now if I want to write them or change them from the standard form into the scientific notation, okay, so look هلا I want to write this in the form of a times 10 to the power n. Now a must be ones. يعني the maximum value, the maximum place value of this number must be in the ones. So I will move the decimal point to have 3 as ones, okay, in ones place. So I will count how many digits did I move it. 1, 2, 3. Okay, so what I will do, miss? Now I will write it in the standard form, like in the scientific notation form like this. Then I will write it 10. Now I have to find n. N equals the number of the let's say the digits that or spaces you have moved the decimal point to. So I move it from the end right, because as we have said before that in invisible math we can say that every number has an invisible decimal point to the right of it. I move it from the end, right end, how many digits or how many spaces? 1, 2, 3, 3. So it's to the power, yes, it's to the power 3. Okay, how many spaces did I move it? It's 3 spaces, so I write it. Okay, let's say if the original number, if I want to move it from the standard or convert it from the standard form to scientific notation, if the original number is greater than or less than 1, I have to see. If the number is greater than 1, the exponent will be positive, as you can see here. Okay, if the number is less than 1, it means that you are talking about decimals, about fractions, okay, and decimals that you have, you don't have, ones in it, so the exponents will be negative. As you can see here, this is positive, this is negative exponent. Okay. Now, if you want to start to change this from the standard form, okay, into the scientific notation form, here you will move the decimal point from the right end, how many digits? 1, 2, 3, 4, 5, 6. So you will make it as 9 point, and you write the rest number, okay, or of the number. Then you will count how many digits they are. 6, so it will be to the power positive 6. Now look here. Now looking at the number and notice that it's a decimal, you will immediately tell that the exponent should be in negative. Okay, now I will move the decimal point, which is existed actually, from here how many digits to reach that I have 3 in ones. Okay, so 1, 2, 3, 4, 5. So it's to the negative, to the power -5, as you can see. Okay, and here is the same. You move it 2 digits to become 8 in ones. Always put in your mind that you want the let's say the largest place value number, okay, or the largest place digits to be in ones. Okay, so you will move it, and here it's the same. So